Hello, I'm the Exhausted Programmer. My name is Alexander, and today's video is part one of a series where I dive into many different languages, some I already know and some I do not. As you can see, there are 21 languages here, but not all are programming languages. I chose these languages based on a few different top 10 lists of popular languages I found online, plus a few more I added because I wanted to add them. I started at the beginning, writing Hello World program for each language. First, let me just lay out the format. Each directory contains at least one programming file and one text document that notes how others can execute these files. Also, everything runs in a bash shell on Ubuntu, so if you want to replicate this, starting with Ubuntu and using the app repository is a great start. There's actually only one language here that needs something beyond the app repository. And if you're using any other Linux distro, I'm sure their repositories got you covered as well. Even with the languages I already had experience writing, I learned some interesting things. We have both ARM and x86, two assembly languages that can be useful these days. What I didn't know was that the style that you write the assembly for either one of them is not dependent on the processor. There's actually two major styles or syntaxes, AT&T and Intel, which makes sense since AT&T gave us Unix and Intel gave us the x86. We can see an example of the AT&T syntax with the ARM program. I stuck with the AT&T syntax, also called GAS for both ARM and x86. It's the one I first learned, it's the one that makes sense to me, and I didn't want to go down every possible variation of each language. Also, when it comes time to write hello world to the screen, I count these as write using the keyword write because that's one of the things I was tracking while doing all this. The reason for that is because it's in the documentation, the function call is write. The way we use it here is by putting the value 4 into the register 7, and whenever we have a software interrupt, according to this documentation, that will call the write function with the values 1, whatever our message and whatever our length, and it will display that text. Then we move 0 into register 0 and 1 into register 7 to set up the exit, which we do when we do the software interrupt here. How we turn these written program files into actual executables can be found in the notes file in each directory. So if we look for ARM, notes.txt, we see first a little warning that this needs to be ran on an ARM processor. I'm currently using the x86 machine. This has been tested on an ARM processor. I do have a Raspberry Pi somewhere that I ran this. But if you have an ARM processor, you can run these commands. We can see with x86, similar programs are used to turn this into executable. There are some differences because, again, it's for an x86 processor and not an ARM processor. The most obvious is that the write function is not value 4, but value 1. Also here, I didn't calculate the length of the string. I just told it what the string's length would be. But the same thing ultimately with moves and system calls or software interrupts. And again, we can just run these commands as they are written. To create the executable, and then we can run the executable. And that works again for every language that we'll see. I will not do that for all of them because they ultimately all give us the same output. There were certain interesting things that came about that I'd like to highlight in this video. If we take a look at the Python code, we can see print hello world, and if we try to run that, it works. What I find very interesting is the fact that this line is the exact same line that we would use if we were to do hello world in Lua or in R script, a simplified version of the R script code. They're all the exact same, and sure enough, we can pass one file into the other interpreter if we want to. R script having a slightly different command. .py. Also, the output's a little bit different for our script, which is why our script, like some of the others, has two different files. And if we go ahead and look at the other one, we can see more lines of code, things that aren't necessary, but how to get rid of the quotes, how to set up a function, how to do comments. I decided there was enough good things here to keep it. One of the things that isn't necessary, but I'm keeping in, is this first line, which can look familiar if you're used to working with R script or other scripting languages. That's only useful if you make the file itself executable. The shell that you execute the file through will look at that line to determine which shell it needs to use. Very often we see this with bash scripts, which is another one of the languages here. And if we go ahead and look at this, we see that line is included. But if we were to run this like this, we wouldn't need that first line. In fact, just the echo hello world would be the only thing needed. So another one-line scripting file. If we go back to the root directory of this project, two languages that stand out as possible not programming languages is HTML and SQL. And I say it that way because HTML is definitely not a programming language, but SQL is. Let's start with HTML. I included it here because HTML is a very important markup language. Even though it's not a programming language, I think it's something that everyone should know if they're programming, because at some point you're going to deal with a website. You might remember earlier where I said everything needs to be ran in the shell and in a bash shell specifically on Linux. Well, same is true with these HTML files. We have two. The first one to look at is hello HTML. Again, we could simplify it, but I didn't want to. We see that there are 9 different hello worlds listed here, and if you were to open this up in a browser, you should see 9 different instances of the phrase hello world. And sure enough, that is what we see. We have the one without the tag, the paragraph tag, the bold tag, header 65432, and header 1 tag right at the top. If we take a look at the other file here, it's just the word hello world, no tags, but not only in links, but also other web browsers, you still get the phrase hello world, and so I think it is valid for the task. The other language worth mentioning in this section is SQL, as I said earlier, and many people don't think of SQL as a programming language, and really it shouldn't be thought of that way. It is a database system, it is very powerful, it does things very well when it comes to that, but I just happen to know that many people don't know you can actually write functions for SQL. And there's an example. We can create a function, give it a name, tell it what to do, what it returns, and then call it like this. The thing is, to run this correctly, you need to set up SQL, you need to give it a database, and you need to give it a user with the correct permissions. It isn't that hard, it's just following instructions online, but it takes some time and I don't want to do it here. It is one of the benefits of the more simple HTML, but we can see that if we did have everything set up, we could run the first one with this line. Of course, I do have everything set up. And if we look at the output file, we see hello world. But if you don't have everything set up, you can get a similar result using the simple SQL, which is just select hello world. There are many ways to group programming languages in this video. We grouped the scripting languages together, at least 4 of them. We could group SQL and HTML as not really programming languages. There is also a number of C languages, such as C, C++, and Objective-C. I am not including C# in this. A lot of these languages are based on C or inspired heavily by C. But with Objective-C and C++, they are both described as supersets of C. So if we take a look at the C hello world file, this is valid C program. It's also valid Objective-C. It is not valid C++ though, which is something I discovered. I'm sure other people know about this. In fact, I know other people know about this because I went looking it up, why it didn't work. But C++ isn't actually a superset of C, as you can have valid C code without it being valid C++. There are 3 more languages, though, I want to note before the end of this video. The first one is COBOL, because it is weird. There's a lot going on, but I only want to point out 2 things. One, the simplest version of the hello world can be seen here. COBOL is set up by having 4 divisions, of which only 2 are here, identification and procedure. This is the simplest file we need to run because you do need a program ID. It does need to go into the identification division. Obviously, we need to display what we want to display and tell it to stop. And those things go in the procedure division. For something that would work better as a first COBOL program that is also Hello World, there is included the hello.cbl file. Here we still have the identification division, but we see the 2 missing divisions, environment and data, which are empty, which kind of makes sense. The thing is in order for this to run, you do need the identification division. As I said, you need the program ID. Up until 1989, you also needed all this other identification lines, but since 1989, they're not required. What you cannot do is create your own divisions or your own lines for the identification division. You can't come up with a line that says team and give it a team name. It will not compile, or at least it would not compile using the compiler that I am using. Next to last is BrainScrew. The name of it isn't actually BrainScrew, but I'm not going to play with the YouTube algorithm. BrainScrew is a programming language that only has 8 valid characters that can be used in writing a BrainScrew script, but I only use 3. I'm using plus, minus, and then the period. The way to think of the language is this: you start with the value of 0, and we want to get it up to 72, which represents H in the ASCII table. Once we have the value 72 by just putting 72 plus signs, then we output it using the dot or the period. Then once that has been put to the screen, we go up to 101, which is the lowercase e, and we display that. We can use the ASCII table to find all the other letters. You only need to go up a little bit more to get lowercase l. Since you're already there, you can display it twice. O, spaces, go way back. And then once we're done with the lowercase d, we have to go all the way back to the value of 10 to get to the new line. That is to say, I have 2 lines of code here that are not necessary other than to make it look good. If we run it, we'll see hello world. H-E-L-L-O space W-O-R-L-D, new line. And the last language I want to look at in this video is locode. If we go to locode, we'll see, again, the programming language file and then the notes file. In the notes file, it points out that this requires something from GitHub. So you cannot get the LCI program from the app repository, or at least I wasn't able to find it. Setting it up is really easy. If you just go to GitHub to this website, the README is pretty clear. Once we have it installed, or even before we have it installed, we can write our hello world. This is, again, another language that uses capital letters for its keywords based on internet speak of a certain time period. This was created in 2007, so from that time period. But it still works just like all the others to give us hello world. Hello world is in development, and by that I mean it's been stuck in development and hasn't made much progress, it seems. But it works well enough that I was able to do a couple of weeks of admin of code one year. So what was the point of this exercise? There were a lot of programming languages that I never would have touched, and some that I'll never touch again. I did learn that Hello World is not a great program to learn a new program, but it is a good program to make sure everything is set up and ready to go. I did pick up on a few patterns, like having a main function or similar notation that basically points to the beginning of the executable code. There's also a data block in many of these programming languages. Many of these languages take a significant concern with what the program is returning when it is done. My plan is that with the next video in this series, I'll take a more thorough look into many of these languages. I'm not sure how many will be in the next video, but the goal is for each one to have at least one function call that isn't the main function, some conditional statements, and looping. I've actually done many of the languages. I started with the ones I thought would be most hard. So I'm hopeful that this video will be out soon, in a week or two. Thank you for watching.